This is Dr. V. Maria Antoniette Martin, Assistant Professor, Department of Information Technology, St. Joseph's College, Tiruchirappalli. In this session, we are going to see the introduction to R programming. Content. What is R? Why learn R? Installing R and RStudio. RStudio interface overview. Basic R syntax. Data types. Vectors. Data analysis and visualization made simple. R is a powerful programming language designed specifically for statistical computing and data analysis. It was developed by two statisticians, Ross Hawker and Robert Gentleman, beginning in the early 1990s at the University of Auckland. The language was publicly introduced around 1993 and has since grown into a widely adopted tool in research, academia, and business. One of R's biggest strength is its free open source nature. It is distributed under the GNU General Public License, so anyone can use, modify, and share it. Because of this, it has become a go-to environment for statisticians, data scientists, and researchers around the world, especially for tasks like data visualization, hypothesis testing, regression, and more. R is a very powerful language used for statistical analysis. It has a huge collection of packages available through CRAN, which helps us perform different kinds of data related tasks easily. R is especially strong in data visualization. Libraries like ggplot2 and plotly allow us to create clear, attractive, and even interactive charts. Because of this strength, R is widely used in academia, data science, research, and machine learning. To start using R, the first step is to download and install R from CRAN, which is the official website that provides R for all operating systems. Once R is installed, you can install RStudio. RStudio is an IDE that makes working with R much easier. It gives you clean and organized workspace. In RStudio, you get a script editor to write your code, a console to run commands, an environment pane to see your variables, and a plot span to view all your charts and visualizations. The RStudio interface has several important panels that make working with R easier. First, the console is where your commands are executed and you can immediately see the results. Next, the script editor is where you are write, edit and save your or programs for future use. The environment and history pane shows all the variables currently stored in memory and keeps track of the commands you have used before. Finally, the plots, files, packages, and help pane is where your charts and visualizations appear, and it also helps you manage files, packages, and documentation. Basic or syntax follows a simple rules. To assign a value to a variable, we use either the less than hyphen symbol or the equal to symbol. For example, x equal to 10 stores the value 10 in the variable x. In or commands start with the as symbol. Commands are used to explain your code, such as this line stores a value. To show output on the screen, we use the print function. For example, print x will display the value stored in x. These simple rules form the foundation of writing code in R. Data types tell us what kind of data a variable can store. In R, there are several built-in data types that we can use. Understanding these data types is very important because it helps us handle, analyze, and manipulate data correctly. The numeric data type is used to represent numbers, including decimal values. In R, numbers are stored as numeric by default. For example, if we write NUM equal to 15.7, R automatically treats 15.7 as a numeric value. The integer data type is used to store whole numbers. In R, an integer must be written with an capital L at the end. For example, age equal to 20 capital L stores the value 20 as an integer. The character data type is used to store text or strings. In R, character values must be written inside codes. For example, name equal to Dr. Anto stores the text Dr. Anto as a character value. The logical data type is used to store values that are either true or false. These values are mainly used in conditions and comparisons. For example, is valid equal to true stores the logical value true in the variable. The factor data type is used to represent categorical data such as groups or categories. In R, factors store these categories as internal levels, which helps in statistical analysis. For example, gender equal to factor of C of male female creates a factor with the categories male and female. The complex data type is used to represent complex numbers which have a real part and an imaginary part. For example, z equal to 3 plus 2i stores the complex number 3 plus 2i in the variable z. A numeric vector stores numbers. For example, numbers equal to c of 10, 20, 30, 40 creates a vector containing 4 numbers. A character vector stores text values. For example, names equal to C of or Python Java creates a vector with 3 character strings. A numeric vector stores numbers. For example, numbers equal to C of 10, 20, 30, 40 creates a vector containing 4 numbers. A character vector stores text values. For example, names equal to C of or Python Java creates a vector with 3 character strings. A logical vector stores true or false values. For example, flags equal to C of true, false, true creates a vector containing 3 logical values. Data analysis or programming helps us take raw information, clean it, and turn it into useful insights. For example, we can analyze sales data to identify trends or understand customer behavior. Visualization or doesn't just work with numbers, it also helps us visualize data through charts, graphs, and interactive dashboards. These visuals make complex information easier to understand and easier to explain to others. Made simple. Modern programming tools come with user friendly libraries and packages that make complex tasks much easier. Because of this, even beginners can quickly create powerful data analyze and attractive visualizations. Thank you for patient listening.